Hi everyone, my name is Lesley. Before I head into the talk, I'm actually going to tell you a really funny story that happened to me. So this morning, so I'm minding my own business, walking from the hotel to the venue, and I was going like under Union Station, I think, and there's like that pathway to walk, and again, minding my own damn business, and this car comes down, and there's like this river of water, and like sitcom level, like they drive over it, and it just splashes all over me, like just completely, like on the way to this talk today. So hopefully that's not an omen, and if it was, then don't tell me. So let's get started. So yeah, hello everyone, welcome to my talk. My name is Lesley Cordero, and I'm currently a staff engineer at the New York Times. So during this talk, we'll talk about platform engineering in the context of Node.js development. More specifically, what platform engineering is and how we can build effective runtime platforms that enable sustainable development, delivery, and release experiences. So before we continue, just going to share a little bit about me. So like I said, I'm currently a tech lead for the New York Times observability team, more specifically, which sits under our wider platform engineering organization. And so as someone who's responsible for the direction of my team and as an engineering leader across all of the times, thank you, I spend my time thinking about the function of our platform story and how it can facilitate success across all of the times. Now, before I was at the Times, I was also a platform engineer, and so this talk is a compilation of the consistent approach that I've brought to each of my roles. And ultimately, what that looks like is coming from a perspective of enabling our department to work in a way that ensures long-term success, while embracing short-term growth opportunities. Sorry. So like I just mentioned, we'll put this in the context of supporting Node.js developers. And so I'll start off by talking about what I even mean when I say organizational sustainability. And more specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. That's what I actually meant to say. And so there's a lot to unpack here, so let's break it down. First, sustainability is a continuous practice. Even if we spend a lot of upfront time thinking about how to ensure long-term sustainability, circumstances change, and often quickly, and we need continuous avenues to ensure long-term success. Secondly, enabling short-term growth opportunities. Sometimes those risky short-term growth opportunities are what lead to long-term success, right? The emergence of bundles of tools or suites of tools has worked pretty well for some companies, including the Times. And so we don't want to give those up, but putting on my reliability hat, we also need to make sure that we're prepared for the risk of those opportunities, which leads us to this component of enabling long-term success. And so we frequently see companies take their core business for granted in the name of growth, but for every successful growth opportunity, most opportunities do fail. Right? Companies with strong core product missions neglect its maintenance and its modernization to focus on a new opportunity that, again, is potentially a large source of risk. And so preparation for this type of risk is essential. So now that we've defined the goal, organizational sustainability, let's define the strategy, platform engineering. And so as much as I hate repeating words on a slide, I'm going to do it, if only for emphasis. So using my definition of platform engineering drives sustainability by practicing socio-technical principles that provide a strong support system for application developers using our standardized shared platform architecture. And these three components form the basis of what it means to provide a developer platform. And so I'll spend the rest of this talk decomposing each of these components, the principles that guide us, the support that enables application developers, and the architecture that we build and use along the way. And so first, we have the principles that guide the rest of our platform. Having focused on reliability management within platform engineering, the principles we'll review are heavily influenced by DevOps, particularly because DevOps principles take a strong consideration for both the technical and social components of what it means to develop and operate software. And so we'll head into those principles. So some of us might have heard of the COMS framework, which was coined by Jez Humble. He's an author of Accelerate, a really popular book in the DevOps space. And this is basically a framework of principles that should be the core of DevOps organizations. And now, while all five could be easily applicable here, I'm just going to focus on three. More specifically, culture, automation, and measurement. And so starting off with culture, the COMS framework tells us that it drives a culture of continuous improvement and reduces toil or silos by intentionally sharing knowledge and feedback. And so you can note that while I removed the S from this framework, its presence still shines through this principle anyway. And the same is true here for platform engineering, though I'll talk about it more directly by putting it in the context of community. And so in DevOps, we often talk about breaking down silos. That's actually the problem where it emerged from. And the way that we abridge that is by sharing knowledge, and to share knowledge ultimately means to connect. And so connection and communication are key for preventing the silos that would hinder our ability to make continuous progress. And when we're talking about organizations, especially as our organizations grow, the most effective way to not only manifest this culture of sharing, but also to improve employee engagement and retention, which are other ways that disrupt organizational sustainability, is to think about how a strong community how to cultivate this kind of community that fosters this culture at scale. And so, because ultimately, right, the opposite of isolation and silos is to be in community with other people. And so next, we have automation, which improves our software delivery process by reducing human error, improving our efficiency, and enabling faster delivery. And so this means thinking critically about the type of work that doesn't require business-specific knowledge, and figuring out whether that work can be consolidated into software that's managed centrally by platform teams. And because in this, right, we can reduce the cognitive load that product engineers often have to indulge by managing all aspects of their software. And this type of work that's important but can be consolidated in an automated way is work that's repeatable and manual, which is what SREs often refer to as toil, or what product engineers might refer to as boilerplate software. Another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether that's vendor solutions or open source solutions. And the reason for this is because we also need to reduce our own cognitive load as much as product engineers do. A lot of our work can require subject matter expertise, whether that's to manage infrastructure or build CI/CD pipelines, et cetera. Reinventing the wheel is not supposed to be the goal and inherent function of platform engineering, no matter how tempting the technical challenges might be. Large companies often set this precedent to build everything in-house, and sometimes it's genuinely necessary, but that shouldn't be our first instinct. And the reason for this is, again, directly tied to sustainability. Hiring for very specific skill sets is hard, and people often leave. And so the question that we should be asking ourselves every time that we develop a new tool from scratch is, what would happen if the engineers who built it left? What if my business was at risk and I had to heavily prioritize our work towards growth opportunities? How much would the maintenance of these be considered a burden versus a genuine value add? Now, I would be naive to not mention the issues of vendor lock-in that often emerge from relying on vendors, which is why I think paying close attention to open standards and open source is an underrated skill for platform engineers. And so using my domain, observability, we have a huge issue with vendor lock-in, often because there's so much drift in the space. But with the emerging OpenTelemetry standard, which targets this exact same problem, we're able to move away from being so couply tied to our observability vendors. And to elaborate on my point about open source just a little bit, it also presents an opportunity to practice good industry and citizenship by being contributors to the standard. And contribution doesn't just mean code contributed, right? It also means providing feedback on use cases, reporting bugs, documentation, and evangelizing their efforts in a way that builds community. Our industry benefits from open source and standards, and so we all have skin in the game because it ultimately keeps our industry moving forward. And lastly, we have measurement. So first, let's talk about the function of measurement, which is ultimately to have feedback loops for whether your work is actually having its intended impact. And these feedback loops consist of both qualitative and quantitative feedback loops for continuous improvement. And the way that this principle connects to sustainability is, again, by eliminating time spent on work that doesn't ultimately lead to business goals. For example, or if a tool that we spent weeks on isn't actually serving our product engineering users, leading to lack of adoption, we've now invested time that could have been directly serving our paying end users. And so we end up missing the ultimate goal of building applications that age well with our evolving product growth opportunities. And so in other words, these feedback loops just keep us on the right path towards a continuous improvement that enables us to build new features while maintaining our existing software. So now that we've defined some principles, we'll shift over to talking about the support strategies for application developers that are integrating with our platform. And so we'll speak to both scalable and flexible strategies and put it in the context with the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. And so the first is the most scalable strategy of all, which is to make building sustainable software easy. And we'll deep dive into this more in the next section when we talk about our platform architecture. But just to set the stage for that, sustainable organizations are directly tied to their ability to build sustainable software. And what we mean by that is software that ages well with evolving business needs. And so I'm sure we've all worked with software that clearly wasn't built with much foresight in mind, right? And this is usually what we refer to as tech debt. And tech debt is inevitable, but we can mitigate its risk by being intentional and strategic about when and where we inject tech debt, right? Tech debt should have a function, which is usually for the purposes of growth opportunities. And tools that aren't easy to integrate with are the type of technical debt that doesn't typically pay off in the long term. So it's especially our duty as platform engineers to build easy-to-use tools to minimize the time that we need to spend supporting developers. Now, that's not to say we shouldn't be willing to support developers, right? In fact, the opposite is true. I mentioned in the cultural principle that sharing knowledge is incredibly important. We just need to be intentional about when the right time to support is. And so we talked about measurement as a principle earlier. An important measurement of our effectiveness is the adoption of our developer platform. And so what intention looks like there is ultimately defining the ways that we approach support and clearly communicating it to avoid any mismatched expectations that will degrade trust between platform and product engineers. And so in the interest of time, I'll only provide one example of this, which is to provide an easy decision framework driven by the status of your tools. And so we don't have a lot of time to review, so just feel free to take a picture while I drink water. All right. So a common pitfall for platform engineers is to take on more integration work or too much integration work. And so like the last slide showed, right, there is some room for that in the early experimental or development mode, but that's not scalable, nor are we often the right people to even be doing that sort of work, right? And so a relatable example here is often like testing, right? Platform engineers can certainly create or recommend testing tools or methods, but we can't be the one writing unit tests for a service that we don't own, right? That requires domain knowledge, and luckily if we're doing our jobs right, then the time that we save them in supporting and providing support frees up product engineering time to take on the application-specific work. And so lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And again, the function of this architecture ties directly to the first support strategy we talked about, to make building sustainable software easy by consolidating efforts and cognitive load centrally. And so we've already talked about our high-level principles, but next we'll review some architecture design principles. And so the first is to embrace domain or design-driven architecture as a core principle. To my final point before, we often have a privilege to move with more intentional design. And this intention is what enables us to minimize the technical debt and risk that leads to unsustainable organizations. And so while this principle can be broken down into many pieces, we'll omit that for now because we're going to talk about design tensions and how to alleviate them in a few minutes. Secondly, our architecture should be complementary to those of our users. When we prioritize our work, we should be driven by the needs of application developers of our organization, whose architecture should be a reflection of our pain end users. And so this is why platform engineering is often a steady rather than a fast revolution. The way that we organize ourselves and prioritize work should ultimately be grounded in the reality of the types of problems that product engineers are facing. And so, for example, right, if we want to improve the runtime experience of developers, we should prioritize the languages actually used by them, not the ones that we want to support first. Sorry, you Rust developers. We're ultimately not here to tell other developers what to do, right? We're here to support them in what they need to do. And the reason that this is so important is because our platform architecture can easily lead to what I would call platform chaos, right? I'm sure we've seen this kind of diagram before. And so, right, an overwhelming number of tools, especially custom ones, is not the goal, right? Tools are enablers of our goal to build excellent engineering organizations. And so instead, we should be managers of chaos, which leads me to the design tensions I mentioned earlier. First, we have what I think is the hardest tension to balance, which is standardization versus flexibility. And so the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift. But we have to hold that in tension with the flexibility that developers often need, especially as our organization grows and the number of technical needs grows with it. So for example, right now my organization is reconciling the consequences of building tens, maybe more, of services with an opinionated framework that has not aged well. And so now we not only have to revisit how we approach runtime support, but we also have to reconcile the tech debt that manifested from this decision years ago. And so that said, reflecting on where we went wrong, but that we're doing now, is to engage with our users more. And so I started off this talk by saying the opposite of isolation is community. And so now we're approaching it from the standpoint by driving standard definitions with actual teams and our learning communities of practice. Next, we have the tension of simplicity and complexity. And so as you respond to evolving needs of your users, right, complexity becomes harder to manage because the architecture that supports them is likely to change, whether that's to begin using event-driven architectures or begin embracing client-side rendered front ends. And so this becomes another area that we need to be intentional about. And just like tech debt, complexity is inevitable, but we can compartmentalize it somewhat by making sure that the developer-facing interfaces are simple. Which leads me to the most common source of complexity in software engineering, which is integrations. And so we know the common principle of reducing coupling between services, right? And the same applies to this type of architecture. Integrations are high risk because avoiding coupling is incredibly difficult, right? This is why a huge selling point for some vendors is their integrations, but those integrations are also what lead us to that lock-in. And so speaking of vendors, remember our automation principle from earlier? Even though I spent some time talking through some design principles, I'm also here to say give yourself permission to not design at all, right? The decision to build versus buy versus reuse open source software should be our bread and butter. And deciding that we don't want to take on the work of building and maintaining a tool is a very valid one. And so holding these tensions in mind, let's talk through what I would call the principle, the platform recipe, and then apply that to Node.js development. And so this recipe is a reusable framework with 4 pillars, and these allow us to embrace, compartmentalize, or communicate the trade-offs of the tensions that we just reviewed. And so together, they ultimately make up our developer platform architecture. And so let's briefly review these and then provide some examples in the context of Node. And so first, we have the parts of our architecture that provide standardization. So 2 examples of how we might do that is through templates or opinionated frameworks. And how much we want to lean into standardization is dependent on the language or use case. And so secondly, we have the parts of our architecture that provide more flexibility. So for example, right, we might modify a framework to become more modular so that developers pick and choose based off their context. And we might also extend the way that we do templating by providing a CLI to make them more dynamic. Thirdly, we have the parts of our architecture that compartmentalize complexity through integrations, since the first 2 pillars should provide the simple interfaces that I mentioned. And this might be APIs that tie in the first 2 pillars together, or plugins to front-end services, front-end interfaces that developers use to provide visibility that they even exist. And these tools are often not directly used by developers in their development and are instead tools that we use to support developers. So for example, the tools that pull technologies together to support on-demand environments. And so engineers will certainly use those, product engineers will certainly use those environments, but the technical details of how we implement those should be abstracted away so that they can focus on product development. And lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs, the standards we set organizationally, or decision records for when we decide to build, buy, or reuse software. It might be a little strange that this is considered part of the architecture, but as I emphasized throughout this talk, and is a theme I think throughout this conference since developer experience, right? Touch points between platform engineers and product engineers is essential. And especially in a world that's embracing and should embrace remote work, right? Software is going to facilitate that. And so documentation is the first obvious one with support channels as complementary. So in the integrations pillar, I mentioned that plugins as an example to provide visibility into the tools that exist. And that's an essential question to answer because visibility is needed to drive adoption. And so let's answer that question of how to provide visibility into our architecture. So especially with the emergence of Backstage, which is an open source project that was created by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem. And so the concept of a developer platform or portal is a compelling one, right? It tells the story of what it means to develop software at your company. And so by providing this unified view, not only does our platform become more visible, it also facilitates visibility into the services using the portal. And so integrations are a crucial part of developer portals, but because it's a centralized entry point, we do have to consider the risk of a singular point of failure. And this is why it embraces the idea of plugins, which are designed to easily be added or removed from the host application without that coupling. And so in other words, right, it provides the similar benefits that we see with microservices by having concrete separations of concern. And so I mentioned how developer portals tell the story of what it means to develop software at your company. And so I want to give a little bit more insight on this before I provide the concrete examples that I keep promising that tie the concepts we've seen together. And so in the interest of time, I am not going to go through each of these steps, but all you really need to know here is that this is the story that we're ultimately telling, the one around our feature development cycle. And so the most relevant ones to us are development, production readiness, and release stages, so those are going to be the ones that I'll focus on for the rest of this talk. And so starting with development, which supports the end-to-end development cycle, particularly runtime and architecture needs. We embrace standardization here at the first part of our recipe through runtime templates, which minimizes repeatable code by centralizing it into that template. And so what this looks like practically might be a server file like this. And so this template not only provides a reusable file, but it also acts as a standardization technique by including our organizational framework of choice, Express. And so from this, right, developers will only need to modify the parts that need service context, which is highlighted here. And over time, right, we could continue to extend this template to also include standards for dependencies like expresses used here, as well as linters and testing frameworks and all of the things, and all of which would be reflected in configuration files or additional boilerplate code. And so when beginning to build out these templates, right, we should start simple and build our way out. Right? Rushing into their development too quickly can lead you down a path towards a developer story and golden paths that don't actually serve the needs of our users. Alternatively, right, you might decide to build the runtime framework that codifies organizational standards. And so you can imagine that as your organization grows its standards, that this template file might become quickly overwhelming, right? So for example, we might extend our functionality to include middleware and to standardize how we write APIs. And as we add more and more of this code to the template file, right, it can become impossible for developers to figure out what's going on. And so sure, like comments can help, but there's a reason that we use abstractions in software engineering, right? And so in an effort to keep that template simple, we can abstract these details away and replace the Express code with our own framework. And so here's what a package code might, what that package code might look like, as well as the simpler service file that we'd now be providing. Now, there's of course many downsides to this, right? This is a fairly large dependency introduction, right? We now have to maintain this code for years, and it's a commitment that shouldn't be made lightly. And it also requires a huge amount of intentional design. But it addresses the drift a lot more effectively because templates are easier to modify, right? Since the internals of the framework isn't code that they own. And so, one of the classic trade-offs of engineering. Now, if you find frameworks to be too inflexible for your organization's needs and want to provide more flexible options, right, runtime packages are a great tool in our recipe. And so here we still have a lot of decisions to make, right, including where on the spectrum of flexible we want to be, since we can still use these packages to inject standardization. And so to ground this in an example, we might have a function, we have this function in a package. And this is obviously a naive example, but this header might indicate something related to authorization that we might want to have a standard for. And in this naive example, right, the standard is that we want to have a header value be all uppercase for whatever reason. And while this function is opinionated, unlike a template or a runtime framework, it's opt-in, right? Meaning that while we want to incentivize developers to use it, we can't really require them to. And again, the goal here is to save developers time that they would have spent writing this code themselves. And so saving this time for a relatively few number of developers might not be that impactful, but as our organizations grow, that time spent building libraries will be paid back in the long term. And so an additional benefit of packages is that should you ever revisit the possibility of building a centralized framework, you already have some of the building blocks that you can use to assemble that framework. And so building modules is often a great first step when adopting platform engineering because it allows you to incrementally build for the needs of our developers without investing a huge amount of effort that a full-fledged framework might require. And so now we move on to the next pillar of the recipe, integrations and plugins. And so extending our example, as our organization grows and our architecture evolves, so might our number of packages, right? This was the second architecture principle from earlier. developers will need visibility into these different packages, so naturally we'll probably decide to integrate with a package manager, which should be managed centrally so that it has clear ownership and so that it doesn't become too bloated with packages or artifacts like those templates. And so conveniently, there might even be a plugin available for your developer portal, so that's even more visible. As an anecdote, NPM and other package managers are integrated with Backstage. So along the way, we'll also need to document our work so that users can use our tools smoothly. And so combining this with the second principle from earlier, finding ways to automate this will make our lives easier and set our docs up to be less stale. And so for Node, right, this might mean integrating with TypeDoc to automatically generate them, which might then plug into our developer portal to render the docs there. And so skipping past the production readiness steps for reasons that will be clearer earlier or later. Next, we have delivery, which supports software development by focusing on infrastructure management and support. And so similar to our development example, we can embrace standardization through configuration templates. And so this ends up looking something like this. And so here, we've provided one YAML file template to represent a very basic deployment. And so now developers have less config that they need to manage their deployment pipelines. And so next, we embrace flexibility through a similar technique from before, modularization. And so you might have assumed that the deployment file that from the last slide was just the one for production, right? But we all probably know that production isn't the only environment that we need to manage. And so for anyone who has ever managed multiple environments, you might know that there's also a lot of overlap in terms of configuration. But there are meaningful differences that isn't just a simple file reuse. And so because of that, right, modularizing the YAML templates we provide by environment can be a way to support each use case centrally so that there's still consistency. And we see similar benefits as we did in the development example, right? That new flexibility that enables engineers to pick and choose which modules make sense for their needs. And it also makes it more maintainable, especially if we extend our platform to embrace a chart generation integration. Next, we have our integration points. And so when it comes to delivery needs, CI/CD is going to be a very important interface here. It enables our automation principle by streamlining the process of continuous integration, testing, and deployment. And so for example, right, let's say we want to provide this template Docker file to containerize our Node.js applications. To support product engineers even more meaningful, right, we can use this as a building block for any CI/CD pipelines that we provide. And so this is also another example of the build versus buy versus reuse open source software tension which is that we'll first need to decide what CI/CD provider we use. Right? We could use an open source solution like Jenkins and build and maintain the pipelines ourselves, but we can also use a vendor that will own the pipelines so that we can focus on managing the vendor solution in a way that's specific to our organization's needs. And so what this ends up looking like is providing a lot of glue between our services and our providers. And so, yes, more config templates, I know. I only defined one stage here, the build stage, but that should be enough to demonstrate how this Docker file serves as an integration point for our CI/CD. And lastly, even though a lot of what we reviewed could be abstracted away from product engineers, we should still provide documentation, both for ourselves and to help products gain visibility into what may feel like a total black box. Right? Because our tools will fail too, and we don't want it to be the case that developers are confusing our failures with theirs. And so we can do this through robust and clever error handling and make it clear when the tool is failing, not the application. Lastly, we have production readiness, which supports the post-delivery needs of software through production readiness techniques. And so this work often builds on top of the examples we just saw. For example, we might extend configuration templates to include features that enable reliability. And so since observability is my focus area, I'll ground that in an example from that space, right? And so let's say we use the OpenTelemetry standard after considering the trade-offs of defining our own standard, using one from open source, or using a vendor-specific one. And so given this decision, right, we choose to embrace standardization further by adding new configuration in the values YAML file to support the standard. And so now developers don't have to worry about managing the config needed to support the OpenTelemetry collector. And instead, they can focus on instrumenting their applications for telemetry that requires service-specific context. Now, switching gears into runtime packages, we could also extend that development experience to include modules that provide features relevant to reliability management. So again, using observability, that might mean providing optional middleware functions to enable collection. And so in this very naive example, we see a similar tension as earlier, where we do standardize the key of an attribute, but we still provide the flexibility of managing a value through an environment variable, for example. And lastly, all of these things quickly become overwhelming, even when they're designed with a lot of intent. And so not only do these decisions need to be reflected somewhere, we need to understand that infrastructure incidents are ours too, and that the process of incident management should be one that fosters collaboration and knowledge sharing, which is a value that is reflected in our principles. And so what this looks like can be a little tricky depending on our organizational structure. But regardless of that structure, driving clarity over what incident management looks like is crucial to avoiding broken trust when our platforms inevitably fail. All right, so now that we've talked through the 3 components of our platform, let's ground this into a concrete example by framing it through the lens of the feature development cycle from earlier. And so starting from the left side here, let's say that we're building a product. Let's say that we're a product developer, building a new Node.js service because that's our organization's primary language of choice or runtime of choice. To get started, right, we enter the developer portal, perhaps Backstage, which is integrated with an artifact manager. We select a bundled standardized service template, enter details like service name, and then an integration generates that service for us using a CLI that uses Node.js templates that have an integration with GitHub. And so now we're ready to develop our service. And depending on our development needs, right, we might decide to utilize organization-specific modules. And from there, we'll continue to use GitHub until the PR process is done. And from there, we'll then enter the delivery-focused part of your platform. And so that Node.js service template we used also includes the configuration templates that we reviewed, so that the CI stage can use these to build, test, perform static code analysis, etc. And since our portal includes a drone integration, developers can easily gain visibility into each of these steps, which is especially useful for when they fail. And if that CI stage passes, right, that CI integration then pushes build artifacts that were generated in that stage, which provides access for the rest of the stages in our pipeline. And so again, right, that developer portal provides visibility through its artifact repo manager and drone integrations. And those artifacts should be used during continuous deployment to perform things like infrastructure management, pre-production testing, etc. And so then, using GitHub or its portal integration, we move on to tasks related to release management, like approvals, release tagging, documentation, etc. And after successful testing and approvals, the service is deployed to production using our deployment templates from earlier, but with additional safeguards like automated rollback features that include metrics to figure out automatic rollbacks. And finally, we've concluded the delivery process and head into maintenance mode, which is supported by the production readiness tools that we use to observe and monitor our system. All right, I breezed through this last section, but before we conclude, I want to bring us back to where we began. So I've made parallels between DevOps and platform engineering throughout this talk. And more than anything, I hope it's obvious how important DevOps has been to this discipline, much in the same way that it has been for SRE. Our systems are complicated because people are complicated. And much like architecture design, this type of culture doesn't just happen, it requires intent. And the most compelling part of DevOps is ultimately the way that it transformed our culture to be one that fosters exactly that, intent. And so I started off this talk by saying that platform engineering is a solution to building sustainable organizations, but perhaps the solution that we actually need is just intent. All right, thank you.